Hi, welcome to the notes where we're going to do a summary of section 10.6 and 12.1 to 12.3. So in this case, if you look at the first three pictures here, those are all pictures of central angles. Okay, and in all of these cases, the angle measures are the same as the arc. Okay, so in this particular case, like if I said that this central angle was 100, then I would know this arc would also be 100. Or if I knew that this arc was 80, I would know the central angle was 80. If it's a diameter that is basically cutting the circle in half, then I know that that must be half the circle, which is 180, which also means that this amount of degrees from here to here would also be 180. It's basically a straight angle. All right, if we look down at the next part here, these are all pictures of inscribed angles. This may be inscribed angles. And the relationship here is that the inscribed angles are half of the arc. So in this particular case, if I know that arc AC is 100, then I know that the inscribed angle is 50. Or in this case, if I know that if I know that this inscribed angle is 40, then I know that this arc that it intercepts with is 80. Okay. Or again, if I knew that, say, this was 60, this arc, then I would know this inscribed angle is half that, which is 30. Okay, so that's the relationship there. Now, one of the other things we talked about, it says the corollary to the inscribed angle theorem is if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Okay, so for example, quadrilateral ABC is inscribed in circle P. Therefore, the measure of angle B plus the measure of angle D is equal to 180. So that is referring to these two angles must add up to 180 if they if that quadrilateral is inscribed in a circle. So if you know one, you can subtract from 180 to get the other one. And we also would know that the measure of angle A plus the measure of angle C is also equal to 180. So here and here. All right. So next is, it says if a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. The converse of that statement is also true. So the example we have here is if line RT is a tangent, then OR, segment OR, must be perpendicular to line TR. Okay, so we know that if TR is a tangent line, then we know that these have to be right angles. And the converse of that is also true, that if segment OR is perpendicular to line TR, if we knew that to begin with, then we would know that RT is a tangent line. Okay, so both ways works. All right, next up is a theorem that says if two segments from the same exterior point are tangent to a circle, then they are congruent to each other. So in this case, again, if both of these tangents are coming from the same point A outside the circle, then this piece must be congruent to this piece. Okay. So now if we summarize theorems 12.4, 12.5, and 12.6, we can see that theorem 12.7 says in a circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. So for this specific example, we would say if segment AB or chord AB is congruent to chord CD. So that's this piece is congruent to that piece. Then we know that segment FE must be congruent to segment EG, which is this piece and this piece. And we also know the converse of that is also true. So if FE is congruent to EG, then AB is congruent to DC. All right, and then last little bit here for theorem 12.8. Theorem 12.8 says, in a circle, if a diameter or radius is perpendicular to a chord, then it bisects the chord or cuts in half the chord in its arc. Theorem 12.9 says the converse is also true. So if segment BA is perpendicular to TV or forms a right angle, so if we know that these are both right angles, then we therefore know that TU must be congruent to UV. Talking about that piece is congruent to that piece, and that arc TA is congruent to arc AB. Oops, that's supposed to be arc. Referring to that piece and that piece. Okay, and the converse of that is also true. So I can just write the converse, that TU is congruent to UV and TA. It's supposed to be an arc again. Arc TA is congruent to arc AB. Then we know that segment BA is perpendicular to segment TB. All right, so that is it for that review. Have a good day and let me know if you have any questions.